Okay. So with integrals that involve an a squared plus x squared, where they're being added together, what we're going to do is use a triangle. We're going to use the right triangle here. When would we be adding up the two squares in a right triangle if you were looking at the sides? That would have to be then use the Pythagorean theorem when you know the two legs of your triangle. In other words, x and a. Right, then the third side would be square root of a squared plus x squared. Right, so that would bring this a squared plus x squared into play from the Pythagorean theorem. And so what trig function can relate x and a? Well, you have two choices, but we're going to pick the one that is nicer, and that is the tangent. So tangent theta equals opposite over adjacent. So the key substitution here is x equals a tangent theta. And so for that one, we're going to use the substitution x equals a tangent theta. Okay. And then the final one that we're going to look at, the final one we're going to look at integrals with, is where we have x squared minus something. So we already did a squared minus x squared. That's when we brought the sign into play. Now we're going to look at a squared minus x squared. Or sorry, x squared minus a squared. Well, the only time we could get one thing to subtract from the other is if the x squared part was a part of our hypotenuse. Right, if the x squared part was part of our hypotenuse, and then the a was some other piece, either of the other two legs, or sorry, it should just be x, then the third side would be the square root of x squared minus a squared. And so to bring those into play, we have two possible trig functions we could bring in. But we want to involve the x, right? The x is the hypotenuse. I want to make that as nice as possible. So with that in mind, we use the substitution secant theta equals x over a, right? Hypotenuse over adjacent. So x is equal to a secant theta. Okay. That way we can have x replace just a simple trig function. If you tried it the other way and thought cosine, that's a perfectly fine thing to think. Then you'd have had cosine theta equals a over x, but then x would be equal to a over cosine theta. But a over cosine theta is the same as secant theta, a times secant theta. So this is the secant theta one. So in summary, what we have here as far as trig substitutions is that if we have a squared minus x squared, then we're going to use the substitution x equals a sine theta. Right? If we have a squared plus x squared, we're going to use the substitution x equals a tangent theta. And if we have x squared minus a squared, right, we're going to use the substitution a secant theta. Okay. And then work with the new trigonometric integral. Work with the new trigonometric integral. Okay, so those are our three substitutions. And what we're going to be now looking at are working out some integrals. And very often, of course, as we've seen, what's going to be required once we've worked out the integral in terms of theta is we will need to go back to the original condition that we set up and use that to compute the other trig functions in terms of theta as needed in the integral. Okay, so that's what we're going to be seeing now as we start to look at these problems. But these are the three key substitutions. Key substitutions.